Hello viewers, welcome to Big Boy Physics, and in today's video we'll be discussing about vectors, that is part 2 of vectors or the third lecture of basic maths. Okay, so before going further into part 2, I would recommend everyone to study part 1 before proceeding to part 2 because we'll be using the results of part 1 to discuss the formulations and all the formulas of part 2. Yeah, before going further, I'd like to just give you a gist about the unit vectors. You must know that if there's a d vector, then the unit vector actually represents the direction along the d vector, but it has a magnitude of 1. Okay, if you try to write mod d cap, then mod d cap would come out to be 1. We generally represent it to be a d and a letter d and a cap on it, or it's also called the hat. Just ignore on the all those calling all the names, just focusing on the mathematical interpretations and abbreviations. So d cap, the magnitude of d cap is given as 1. So if you want to define a vector, then the direction along it is given as a vector by magnitude of a vector. Okay, now we'll be using this thing itself in vector resolution. So starting with resolution of vector. Well, in the beginning of the basic maths lecture, I told you to learn a little bit of coordinate geometry also. Hope you have done that homework. If you haven't done, I hope you remember at least few points of coordinate geometry, that how to determine a point on the plane. So that's it, what we define. Now, taking a Cartesian coordinate system, there are two types of coordinate system. I later discuss about the polar coordinate system when it will be required in this vector topic itself. Okay, this is y-axis, this is x-axis. I represents a point to a point P, then P is given the position vector of this point P in the Cartesian coordinate system with respect to O. Then we write the OP vector. OP vector is written somewhat like this. Let me make it using a line better. Yeah, OP vector is mentioned like this. The tail is O and the head is P. So this is the OP vector. Now observe that this point P has coordinates x comma y, and this makes an angle theta. Let this OP vector has magnitude small a. Now can you tell x? X is basically a cos theta. Similarly, y is given as a sin theta. Consider a unit vector along the x-axis, that is along the x direction. This unit vector is represented as I cap. Now observe that this x direction is a fixed direction. So I can say that I cap is a fixed vector. Similarly, I consider another fixed vector j cap. J cap is basically the unit vector pointing along the y direction. Now this actually, if you multiply this I cap with x, then you'll get this to be xi cap, and if you multiply the y coordinate with j cap, you'll get this. I'm representing with orange color, this as the yj cap. Now using parallelogram law of addition, you will get this op vector is equals to xi cap plus yj cap. If you consider it considering the trigonometric function, you'll get a into cos theta I cap plus sin theta j cap, and the angle between I cap and j cap is obviously 90 degrees. This is nothing too much about mentioning about this. If you find the op vector magnitude, you will get it to be a, right. So when you try to resolve the vector into components, we are considering here to be 2D coordinates first. Then we can write the position vector of point P or the OP vector as the summation of the x coordinate into the I cap, that is the vector pointing along the x direction, along and summation with the y coordinate into the j cap, that is the vector unit vector pointing along the y direction. And this is the way we resolve the vectors. Similarly, in 3D coordinate system, let me take another axis. This is the 2D coordinate system. This is x, this is y, And now introducing another axis. This is called the z axis. Yeah, this is the z axis. Suppose a point represented by x, y, and z, and this o p represents the required vector. Let this magnitude be a. Now similarly, if we define I cap, j cap. Now in case of z axis, we define a k cap which is perpendicular to x and I and j cap. So this k cap is basically a unit vector pointing towards the z direction. Observe that ij cos theta is cos theta in each of the case, since these are mutually orthogonal. So I say that I cap mod I cap, it is 1 into cos theta, where theta is the angle between two mutually perpendicular orthogonal axes, is equals to 0 always, because in each case theta is pi by 2. Hence I can say that this OP vector is equal to xi cap plus yj cap plus zk cap. This is the way to resolve the vectors in the 3D coordinate system. Now assume that the angles between the OP vector and x be alpha, this OP and y be beta, and OP and z be gamma. Then I can say x is equals to a cos alpha, y is equals to a cos beta, and z equals to a cos gamma. So I can say OP vector is equals to a into cos alpha I cap plus cos beta j cap plus cos gamma k cap. If you take the magnitude, of course the magnitude will come out to be a, because we already denoted the length of OP to be a. Mod OP is equals to a. Hence, just doing the required summation, in case of 3D coordinate system, we'll do what? We'll be considering two vectors, cos alpha I cap plus cos beta j cap. Using the associative property of vector addition, you will get under root cos alpha. What is magnitude of cos alpha I cap plus cos beta j cap? Magnitude square plus cos gamma square magnitude plus 2 into this vector I cos alpha I cap plus cos beta j cap and cos gamma k cap. These two vectors I'm marking with red colors. I'm indicating this first vector and this second vector. Observe that they will be perpendicular to each other. Why? Because this cos gamma k cap basically points towards the z axis, and cos alpha I cap plus cos beta j cap basically remains in the xy plane. Thus both will be orthogonal, so that the cos theta in this term will be 0, hence the other term will be 0. Of course, expanding this again, you'll get cos square alpha plus cos square beta plus cos square gamma, and the angle between 2 into cos alpha into cos beta I cap mod j cap into cos theta, where theta is the angle between the cos alpha I cap and cos beta j cap, which will be again 90-degree, because they point towards the x axis and the y axis. Hence, just keeping this to be 0, you will get a under root cos square alpha plus cos square beta plus cos square gamma is equals to a. Hence, cos square alpha plus cos square beta plus cos square gamma is equals to 1. That's the result. So you must remember this. And there may be some cases where you will be asked that the vector a vector is actually equally inclined to x axis, y axis, and z axis. If a vector equally inclined to x, y, z axis, then what we say is alpha is equals to beta is equals to gamma. Hence we will get cos alpha is equals to 1 by root 3. Since we are taking it along the positive x, positive y, and positive z axis, so we are taking the positive cos alpha value, right? Hope you get this point. So this is the method we can use to resolve the vector in 3D coordinate system. Now let us look at a problem. Yeah. So this is the problem. This I have taken from H. Verma. The problem says that here you are given a vector 4 I cap plus 3 j cap, another vector b vector that is 3 I cap plus 4 j cap. Then you have to tell me the magnitude of a vector, magnitude of b vector, magnitude of a plus b vector, and magnitude of a minus b vector. Okay, so let's get started. First question is about magnitude of a vector. Magnitude of a vector will be basically under root 4 square plus 3 square is equals to 5. If remember this thing, that if you are given a vector is xi cap plus yj cap plus zk cap, then magnitude of a vector is given as under root x square plus y square plus z square. The similar thing is done here. Since the z component is 0, we'll get 0 square addition with here. Hence, the magnitude of a vector will come out to be 5. And magnitude of b vector will come out again 5. Just try check it once. Now my quick question to the viewers: are these two vector a vector and b vector equal? Well, no. If you find a cap would be a vector by mod a. You'll get it to be 4 I cap plus 3 j cap by 5, and b cap would come out to be 3 I cap plus 4 j cap by 5. Observe that these two are unequal. These two are unequal. That is why you can say that this a mod a vector is equal to mod b vector, but a vector is not equal to b vector, since a cap is not equal to b cap. So another condition we get for equality of vectors is the if a vector is equals to b vector, then a cap is equals to b cap, and mod a is equals to mod b. Okay, so hope you got till this second. Now third is asking a vector plus b vector. Just simply putting a vector and b vector, adding with respect to components, which will come out to be ax plus bx I cap plus ay plus by j cap. Now, if you have two vectors, a vector is ax I cap plus ay j cap plus az k cap, and b vector is ax I cap plus ay j cap plus az k cap. Now adding both of them, a vector plus b vector, you will get ax plus bx. Yeah, here it will be bx by bz instead of ax by z. Ax plus bx I cap plus ay plus by j cap plus az plus bz k cap. Right? If you introduce another c vector, just put another plus cx plus cy plus cz. Okay, but if the coefficient, that is I cap, the coefficient of I cap we only considers the x coordinate, x components. I cap will add to I cap, but I cap cannot be added to j cap. Yeah, it can be vectorially added, but to find the exact one, we'll be adding the respective components to find the net resultant. So the thing we have done is ax plus bx I cap plus ay plus by j cap. We added the respective components of I cap direction and j cap direction. We'll get it to be 7 I cap plus 7 j cap. If you find the resultant, you will get 7 root 2. Now, part D, that is asking about a vector minus b vector. Well, I'd like you to take it as a homework. This is pretty easy. You don't need to use much amount of brain. A vector minus b vector, the same thing we'll be doing, just multiply b vector with a minus sign and adding with a vector, and probably the answer would come out to be root 2 units. Okay, hope you get it. Now another question let me take for you is this question you can take. Suppose you have two vectors, a vector is equal to I cap plus j cap plus k cap. If it is written I cap plus j cap plus k cap, then you must assume it defaultly as 1 I cap plus 1 j cap plus 1 k cap. Okay, don't think that these are empty spaces. These are actually by default written as 1 I cap plus 1 j cap plus 1 k cap. Similarly, b vector is equals to 2 I cap plus 3 j cap plus take it 5 k cap. You'll get it to be, then adding both of them, you'll get a vector plus b vector is equals to 3 I cap plus 4 j cap plus 6 k cap. Taking the magnitude, you will get 25 plus 36. I guess it would come out to be root 61 units. Okay. Now take another question just for practice. This is my y-axis. This is x-axis, and I am denoting three vectors. First is the OA vector. This is point O. Then OA vector is at an angle 30 degrees and it has length of 2 meters. And BC vector, BC, BC vector, this BC vector is at an angle 60 degree and length 1.5. And DE, D is at a point somewhere between the X, O and B. DE vector is at an angle 90 degrees and is of magnitude 1 meters. Then you have to find the magnitude, x and y components, and angle with the x component, x axis, with the resultant of OA vector plus BC vector plus DE vector. The question says, then OA vector, consider the vector OA vector plus BC vector plus DE vector. You have to tell the magnitude, direction, and x and y components. Okay, pause the video, give it a try. Let's get started. I'm starting it. Yeah, observe that OA is 2, so I can write OA to be 2 cos theta, what it will come out to be root 3 I cap plus j cap. Similarly, OB will come out to be 1.5 by 2 I cap plus 1.5 root 3 by 2 j cap minus OB will come out to be, observe in case of OB, B, C. B is the starting point and C is the ending point, but it is towards the negative x direction and positive y direction. So we will write it to be minus 1.5 I cap by 2 plus 1.5 root 3 by 2 j cap. Similarly, DE is pointing towards the negative y direction. I will get it to be minus j cap. Adding all of them will get the resultant. It will come out to BC vector rather. Resultant, uh, it will come out to be root 3 minus 1.5 by 2 I cap plus 1.5 root 3 by 2 j cap. And that's the answer to question number 5. If you try to evaluate it, you will get it to be 1.73 minus 0.75, that is 0.98 is the x component, and y component is 1.73 into 1.5 by 2, multiplying with 3 by 2, 7551. You need to do some speed calculations to solve them. 5.2 by 4, and that would come out to be nearly 1.3 meters. 1.7 in 3 into 3, it will come out to be 5.19. 5.19 can be approximated as 5.2, and division by 4 will get 1.3. So basically I can say that the net will come out to be 0.98 I cap plus 1.3 j cap. You can find the direction, then other stuffs like the magnitude will be the square summation of these two. Okay, so we are done with this problem. Coming to dot product and cross products. First, we'll be talking about the scalar product. That is dot product. Suppose you have two vectors, A vector and B vector, and this is A vector and this is B vector. Suppose the tail joining the vectors makes an angle, means we are joining the tails to each other, and these two makes an angle theta with each other. Then we define A vector dot B vector as mod A into mod B into cos theta. This theta is the angle between A vector and B vector when we join their tails with each other. Hope you get it. So basically the dot product is given as A dot B, A mod A into mod B cos theta. Suppose these vectors are orthogonal, there will be special cases. First case is vectors are orthogonal. I've used this term orthogonal number of times while teaching you vectors. You must know that orthogonal means perpendicular vectors. Okay, so if the vectors are perpendicular, you mean that theta will be 0. It means that a dot b will come out to be a null vector in this case. Second thing is, if a and b are parallel and pointing towards the same direction, then a dot b is given as mod a into mod b with a plus sign. And third case, if all the same but it's anti-parallel, then you will get a dot b is equals to minus mod a into mod b. Basically, this will come out to be a negative quantity. So we are done with the dot product, and now we'll be learning the uses of dot product. Suppose you have two vectors, a vector and this is the b vector. You want to find the component of a vector along the b vector. What you would do is find a cos theta. A cos theta is the magnitude of the component of a vector along the direction of b vector. Okay, the answer would be mod a cos theta. But can you derive mod a cos theta in a different way? A dot b is given as mod a into mod b cos theta. So I can say mod a cos theta is a dot b upon mod b is equals to mod a cos theta. Hence, this is the result we need to find the projection of one vector on the other vector. Okay, hope you get it till now. Now, just jumping into some problems. My first question in this topic is, suppose there are two vectors. A vector is given as 2 I cap plus 3 j cap plus 4 k cap, and B vector is given as 3 I cap plus 4 j cap plus 5 k cap. My question is, find angle between A vector and B vector. Well, one thing, those who have done vectors a little bit more than these, means they have already completed vectors or done till cross products and dot or everything, then one thing you must know, that whenever we try to find the angle, we generally take the dot product, not the cross products. I'll be explaining you why we take the dot products. Just stay with the flow. Find the angle, what we'll do that a dot b is equals to mod a mod b cos theta. 6 plus 12 plus 20 is equals to the magnitude of a will come out to be root 29 into root 50 cos theta. So the answer will come out a little bit of wired, I'd rather say. You'll get cos theta to be somewhat like, in the denominator it will be root 1450 in the denominator, and numerator will come out to be 38. It's a very dirty answer, just for calculation practice they have given. Okay, hope you get it till now. If you want to do more problems, you can refer to H.C. Verma or B.M. Sharma, any other J books you want. Okay. Now these lectures are actually mainly devoted to JE. So the initial phases are for JE. Then later you'll be discussing a little bit of Olympiad stuff, which you means the formula which will require in Olympiads, all those. Okay. So now focusing on this lecture only. Now we'll be talking about the cross products. Just a minute. Yeah. Cross product. So yeah. Now cross product is also known as the vector product. Why it's called the vector product? Unlike in dot product, where we get a scalar as the answer, in cross product the answer will actually come out to be a vector. Okay. Now before discussing about cross product, I will like to discuss with you about determinants. Determinants. We'll be talking about 3 cross the determinants only. Suppose what we do is, in case of determinant, we consider a 3 cross 3 matrix. The values I take is A, B, C, E, F, G, I, J, K, or you can take it like this. Let me reframe it: A1, A2, A3, B1, B2, B3, C1, C2, C3. Now this with determinant basically gives me a certain value. How to evaluate this value? Look at the A1. Look at this A1. I am marking with dotted lines. Cancel all the elements in its row. Cancel all the elements in its row. Put a plus sign before it and observe these elements: B2, C2 and B3, C3. This itself form a different matrix. Now what we'll do, we'll cross multiply B2 with C3 and B3 with C2 and take the difference. Basically we'll do it like B2 C3 minus B3 C2. Okay, hope you get it. Now next term what we'll be writing is of B1, all those stuffs. Just let me rub all this mess. Now look at B2C B1. Look at this B1, I'm marking with orange color. Cancel all the elements of its row and its columns. Then observe that the leftover are A2, C2 and A3, C3. Start with the left hand side always. But before writing the next, first we'll be putting B1 here with a minus sign, because it's the second element. So for odd number element there will be a plus sign, and for the even numbered element it will be a minus sign. Just know this much for now. Start with the left hand side and the upper left corner, A2 with C3. You write A2 C3 difference with A3 C2 minus A3 C2. Now coming to C, I hope you got a bit of idea about it. Mark the C with red color. Cancel all the elements of its rows and columns. Start with the upper left corner, that is A2 with B3 and A3 with B2. First A2 B3 minus A3 B2 would come. Now considering that C1 is the odd element because it's the third element of the row, so we'll put a plus sign and it would come out to be C1 into A2 B3 minus A3 B2. Hope you get it. Well, this is a topic from determinant. If you want to know about it more, you can refer to any mathematics book of class 12. We'll get matrices and determinant. Just look up for only 3 cross 3 matrix. It would suffice for the physics course for now. Now let's jump into the cross products. Now we'll be talking about the real cross products. We define two vectors, A vector and B vector. Then the cross product which we define, A vector plus A vector cross B vector, is defined as, if we take the magnitude, it will come out to be mod A vector into mod B vector sine theta. In this case it comes out to be sine theta. Now you'll be wondering what is the vector term here. Okay, just bringing it now. Suppose this is my A vector and this is the B vector. If you remember about right hand thumb rule, in right hand thumb rule, what we do is that to find the magnetic field about a wire, which I have already studied in class 10, we hold the wire pointing our thumb towards this direction, and the direction in which our right hand would curl, it will be giving the direction of the magnetic field. The same thing we'll do in the opposite sense. That is, consider this theta, and theta should be obtuse or acute. That is, theta cannot be reflex. Remember that theta will belong to 0 to 180 degrees only. Then only we'll be using this right hand thumb rule. Now in this case, put the put your right hand, put your right hand, or better to say right wrist, on this A vector, and the direction you curl should be along the V vector. You can see, observe that this curls along this direction. So you will be able to curl your right hand towards the B vector from the A vector. Then the direction in which the thumb points basically give the direction of the A cross B vector, right? So this much you must know. Now how to evaluate the cross products? Suppose you have vector, a vector is ax I cap plus ay j cap plus az k cap, and b vector is bx I cap plus by j cap plus bz k cap. Hence I can say a vector cross b vector is equals to the determinant, put I cap, j cap, k cap here, then put the terms of a, put the components of a vector in the second row, that is ax, ay, az, and put the components of b vector along the third row. You will get bx, by, bz. Opening this determinant, you will get a I cap, ay, bz minus by, az minus j cap, ax, bz minus az, bx plus k cap, ax, by minus ay, bx. So this will give me basically the cross product, and this is basic, this will come out to be a vector, right? And this way we can find the cross product of the two vectors. Well, previously I said about that we cannot find the angle between angle between two vectors using cross product. Let me explain why. So we will get the angle to be sine theta. Sine theta will come out to be a cross b by mod a into mod b. Now problem is that if theta is, suppose you get 30 degrees, we get sine theta is equals to half, then theta can be 30 degrees or 150 degrees. Both are possible because in the second quadrant sine theta is positive. That is why we do not take cross product to find the angle. But if you get cos theta to be root 3 by 2, you can say that theta will be 330 degrees or 30 degrees. But since 330 degrees is a reflex angle, we generally do not consider. For even if you consider 330 degrees, it would be okay because it would be somewhat like this. The first case you will get 30 degrees like case. In second case you will get 330 degrees like this. If you try to find the acute angle, you will always get it to be 30 degrees. The acute angle is defined as 30 degrees. So there's not much problem in dot product as you'll face with cross product. Okay. Now a quick question for the viewers. This is also asked in HC Verma. Mod of A dot A cross B. What would it be? So just try it once. Okay. Now if you remember that this is A vector, and in the plane of paper this is B vector. Put your hand in the A vector. Think that you are putting your hand on the A vector. Okay. I put my hand on the A vector, and here's my right thumb pointing. If you try to curl it, it should curl towards the B vector. So the right hand is pointing towards the upward direction. Observe that this direction is perpendicular to the A vector. So A cross B is perpendicular to A vector. Hence we can say that the dot product should come out to be 0. This should come out to be a 0 vector, and if you take the magnitude, it would come out to be 0. So now let's start with some problems. The first question. Okay, the first question is, find a unit vector parallel to the cross products A cross B, where A vector is defined as 3 I cap minus 5 j cap plus 10 k cap, and B vector is defined as 6 I cap plus 5 j cap plus 2 k cap. You have to find A cross B, that unit vector parallel to A cross B. So let's get started. First we'll find A cross B just by using the standard determinant notation. I j k, 3 minus 5, 10, 6, 5, 2. You'll get it to be minus 10 minus 50 minus 60 I cap, minus 60 I cap minus j, 60 minus 6, 60 minus 6, minus 54 j cap plus k cap into 6 minus 60. And if you do the evaluation, you'll get minus 60 I cap minus 54 j cap minus 54 k cap. Hence, now just to find the direction, if you find this magnitude of A cross B, probably I have again done some mistake, some kind of, yeah. So it will be 60 minus 6, yeah, it will be 6 minus 60, 6 minus 60, and in k cap it will be 15 plus 5, 3 is 15 plus 6 5 is 30, we get 45 k cap, 45 k cap. Hence, the final result will come out to be 60 I cap plus 54 j cap plus 45 k cap. If you find mod A cross B, you'll get it to be root 8541. Hence, the required n cap will come out to be A cross B by mod A cross B, which will come out to be minus 60 I cap plus 54 j plus 54 k by root 8541. And that's the answer. So this question was a little bit of calculation. I hope that this much calculation does not comes in the paper. Now another utilization of cross product is, if you know about little bit of geometry, then if you have a triangle A, B, and C, and angle is between them is theta, by geometry, if you study geometry, you'll get that the area of the triangle delta is given as half AB sine theta. Now, if these are given as A vectors and B vectors, can we write it as half times magnitude of A cross B? Okay. So this is a theorem you must remember for the next upcoming problem. That is, find area of triangle determined by 3 I cap plus 4 j cap and minus 3 I cap plus 7 j cap. Okay, they are asking just to find the area. 3 I cap plus 4 j cap cross minus 3 I cap plus 7 j cap. I j k 340 minus 370. So I component and j component will come out to be 0, but k component will come out to be finite. That will come out to be 21 plus 12, which will get 33 k cap. Taking the magnitude, we'll get 33, and halving it, we'll get 33 by 2 is the area, whatever in unit square, and that's the answer. Now, let me ask you another method. Let me show you another method. That is 3 I cap plus 4 j cap cross minus 3 I cap plus 7 j cap. Now, just open the way you opened in case of A plus B into B plus C into C plus A, that is this distributive property. Using distributive property, you get 3 I cap cross minus 3 I cap. 3 I cap cross minus 3 I cap, or you can write it to be minus 9 I cap cross I cap plus 3 into 7 I cap cross j cap plus 4 into minus 3 j cap cross I cap plus 7 into 4 j cap cross j cap. Now I cap cross I cap will come out to be 0 because they both are collinear and parallel to each other. So it will come out to be 0, and I cap cross j cap will come out to be k cap, because when you define the Cartesian coordinate system, if we put our right hand on the x-axis and curl our fingers to the y-axis, the direction we'll be getting is towards the z-axis. So I cap cross j cap is equal to k cap, and j cap cross I cap is equal to minus k cap. You'll get the answer area to be 33 by 2 unit squares. Now similarly, we'll be now defining a mnemonic. If you want to use distributive property, then do I cap, j cap, k cap. I cross I is equals to j cross j is equals to k cross k is equals to 0. Now, if you take the product clockwise, I cross j, sorry, anti-clockwise, but I would say anti-clockwise here. I cross j, I cross j will give us plus k cap. J cross k, again going anti-clockwise, will get plus I cap. Now, j cross I am going in the opposite direction of the flow. I am going in the clockwise direction. So, I will get the k cap with the minus sign. Okay. So what I'll get is I cross j is equals to k cap, j cross k is equals to plus I cap, and k cross I is equals to plus j cap. J cross y is equals to minus k cap, I cross k is equals to minus j cap, and k cross j is equals to minus I cap. So these are few theorems you must know for upcoming problems. Okay. Now last problem of the session is prove that vectors A 3 I cap plus minus 2j cap plus k cap, b vector I cap minus 3j cap plus 5k cap, and c vector is equals to 2I cap plus j cap minus k cap forms right angle triangle. Okay, so just try this question once. Well, this does not represent the position vector of ABC. If anyone has learned about a lot of vectors, then this does not represent the position vector. Rather, they represents the legs of the triangles. Okay. To solve this, what we'll do is find A dot B, B dot C, and C dot A, and find which of them equalizes to 0. Observe that C dot A comes out to be 0. Even evaluating, we'll get 6 I cap minus 2 J cap minus 6 minus 2, and here it will be minus 4k, sorry, minus 4k cap minus 4 will get it 0. Remember, if you want to find dot products between two vectors, ax I cap plus ay j cap plus az k cap dot bx I cap plus by j cap plus bz k cap. In this case also we will be using distributive property where I dot j is equals to j dot k is equals to 0. All the mutually perpendicular orthogonal vectors will come out to be 0, and I dot I will come out to be 1. So basically A dot B will come out to be ax bx plus ay by plus az bz, and that's the answer. And that's all for today. In the next video I'll be taking up scalar triple product and vector triple product. These are not taught in JEE, and I'll also take up few problems for uh, cross multiplication and dot multiplication, that is cross products and dot products, for more clear understanding. Okay, that's it for today. Thank you and have a nice day.